Video, we are going to learn about logarithmic functions. So logarithms are used to describe the inverse of a power. In other words, it is the inverse function of exponential functions. And since they're number systems based on powers of 10, the standard logarithm is a log base 10 of x written as log x or log base 10 of x, which is the inverse of 10 to the power of x. Logarithms can have bases other than 10 though. Here are some strategies to evaluate them. So here's a graph of y equals 10 to the power of x. I'm just going to redraw this in blue here so you can see that's the exponential graph. And if we want to find the inverse, as we've learned before, we're reflecting over the line y equals x. And when we do that, we're going to get this graph here, which is the inverse of 10 to the power of x, or in other words, it's called log x. So to understand what logarithm is, we're going to consider the coordinates of the graphs with these functions, 10 to the power of x and log base 10 of x. So for y equals 10 to the power of x, here's a table of values for a few points. So we're considering x equals 0, x equals 1, and x equals 2. And then the coordinate points are then going to be 0, 1, 1, 10, and 2, 100. If we want to find our log x and find some points for it, we're going to use the same rules we use to find the inverse functions by switching the x and y coordinates. So that means my new function for log x should have points 1, 0, 10, 1, and 102. Now let's look at the table of values for it as well to confirm it. Okay, so if I put in x equals 1, what I'm going to actually do is find 10 to the power of what gives us 1, and that's 0. Looking at the next one, the question I'm going to ask myself is 10 to the power of what gives me 10, and that's 1. And then for the last point, 10 to the power of what gives me 100, and that's 2. So if I write down the points, you're going to get points 1, 0, 10, 1, and 102. And if you compare between our two table values, our points are very similar, but our x and y are just switched. So here's a summary of logarithms. The logarithm of a number is an exponent. Log base b of c is the power to which b is raised to get c. The base of the logarithm is the same as the base of the power. And lastly, when log base b of c is equal to a, then we can write c is equal to b to the power of a, where b is greater than 0, b is also not 1, and c is greater than 0. So now we're going to apply this into actual examples. We want to write each exponential expression as a logarithmic function. I'm going to write a rule here that you can use on the side. So the format of the logarithm is as follows. Log base, the answer is equal to the exponent. And this can be related to, in exponential form, your base to the power of whatever exponent you have is equal to the answer. And we're going to use these rules to switch back and forth. So if I'm given exponential form, it changes to logarithmic form. I'm going to look at my base, and that would be the tiny subscript number by our log, which is 2. Then I'm going to insert the answer. In this case, that's 32, which is equal to the exponent, and that is 5. Let's try another one. Our base is 3. Our answer is 1 over 81, and our exponent is -4. And our last one here, our base is 7, our answer is 1, and our exponent is 0. Now let's look at the other way around when we're giving a logarithmic expression and we want to change it to an exponential expression. So our base is here. This is the answer, and this is the exponent. So that means we have a base of 3, our exponent is 4, and this should be 81. For the next one, our base is 5, our power is 3, and our answer is 125. Lastly, our base is 6, our exponent is 0, and our answer is 1. And all of these, again, should make sense. We know that 6 to the power of 0 is 1, 3 to the power of 4 is 81, and so on. In this next example, we're going to evaluate logarithms. When you're thinking about how to evaluate logarithms, the same sort of question is saying 3 to the power of what gives us 729. And in this case, 3 to the power of 6 will give us 729. Here's another one. 2 to the power of what will give us 1 over 32. This is very similar to us solving for x if we have an exponential. So I can just change 32 as a base of 2, which is 2 to the power of 5. Then I can bring this 2 to the power of 5 back up if I negate my exponent. So then x is equal to -5. Then lastly, I can rewrite our radical form into exponential form, which is log base 2, and then 4 to the power of 1/3. If you don't remember this rule, I can write this rule down on the side, but you should have learned this in your previous years, that the square root of, let's say, some number is e to the power of 1/2. Or let's just say you didn't have a square root, but you had a cube root instead. This is the same thing as saying e to the power of 1/3. So in other words, the exponent that's on the inside of the bracket that's associated with a is going to be in the numerator, and then whatever you are rooting by, whether it's 2 or 3, that will be in your denominator. So this is a rule of radicals that you should have learned before. Okay, so this is what we have, and we can say this equals to x. So 2 to the power of x is equal to then 4 to the power of 1/3, because our base is 2, our exponent is x, and whatever's on the inside of your logarithm, that is your answer. I can rewrite this 4 in terms of the base 2, so that's 2 to the power of 2. And then we have a power to a power, so that's 2 times 1 over 3, which is 2 over 3. So then now we have the same base, x is 2/3, and that is our answer. Now I want you to try all this on your own, and then when you're ready, press play for the solution. All right, so for this one, we want to change it into a logarithmic expression. Our base is the subscript with our log, which is 5. Our answer is 1 over 25, and our exponent is -2. Now changing our log form into exponential form, our base is 4, our exponent is -3, and our answer is 1 over 64. Lastly, you want to evaluate log base 3 of 1 over 27. You can see this is equal to x and change it to exponential form. So that's 3 to the power of x is equal to 1 over 27. And just by looking at this, I can tell that x is going to be -3. Negative because 27 is on the bottom of the fraction. We have the reciprocal of it. And I also know 3 to the power of 3 is 27.